take a look at our world. From the silent void of space, it's an icon, a symbol of life itself. The blue marble. Swirls of white cloud drift over a deep, profound azure that speaks of vitality, of dynamism, of home. 71% of our planet's surface is covered by it. Water. The oceans are the cradle of life, the engine of our climate, and the keeper of our planet's deepest secrets. They are so vast, so permanent that we rarely stop to consider their existence. They simply are. But what if they weren't? What if, in a single, inexplicable moment, every ocean on Earth, from the shallowest coastal shelf to the crushing dark of the Mariana Trench, simply vanished? Not evaporated over millennia, not drained through some colossal plug hole, but gone. Instantly. One moment, the Pacific, the Atlantic, the Indian, all of them are there, and the next, a gaping, raw, 360 million square kilometer wound on the face of our planet. This isn't just a question of a lower sea level. It's a scenario that would rewrite geology, climate, and life itself in a matter of hours. The world we know would cease to exist, replaced by something utterly alien. The blue marble would become the brown marble, a desolate sphere of dust and rock. This is a journey into a world without its heart, a thought experiment that peels back the very skin of our planet to reveal the terrifying and awe-inspiring machinery that lies beneath. We will walk the dry seabed, stand on the edge of chasms deeper than any canyon on land, and witness the birth of a climate so violent it makes the worst storms in human history look like a summer breeze. We would unearth mysteries buried for millions of years, from colossal mountain ranges to the graveyards of ancient leviathans and lost human vessels. It's a catastrophe of unimaginable scale, but it's also the ultimate exploration. So take a deep breath of our moist, stable air while you still can. Because we're about to plunge into the abyss, to witness the first 24 hours of a planet that has lost its soul, and explore the new, terrifying world left behind when the oceans drain. The first sign isn't a sound. It's a silence. The eternal rhythm of the waves, the background roar that has filled the ears of coastal dwellers for all of human history, simply stops. All at once, across every coastline on the planet, the sea is gone. For a person standing on a beach in California, one moment they see the Pacific surf. The next, they are standing on the edge of a cliff, a dizzying drop opening up before them into a vast, damp basin that stretches to a horizon now impossibly far away. The immediate effect is geological pandemonium. For eons, the colossal weight of 326 million cubic miles of water has been pressing down on the oceanic crust. That's over 1.3 billion trillion kilograms of pressure, constantly flexing the tectonic plates beneath. When that weight vanishes in an instant, the planet's crust responds like a compressed spring suddenly released. The phenomenon is called isostatic rebound, and it would happen on a scale that defies comprehension. The ocean floors would bulge upwards, in some places by hundreds of meters. This sudden, violent shift would not be gentle. It would trigger a continuous, planet-wide series of earthquakes. Not just tremors, but megaquakes, shaking every continent simultaneously. Fault lines that have been dormant for millennia would rupture. Cities, already perched precariously on the edge of newly formed chasms, would crumble into dust. The seismic energy released would be thousands of times greater than all the nuclear weapons on Earth combined, a constant, world-ending vibration. While the ground heaves, the atmosphere is thrown into its own special kind of chaos. The oceans are the planet's largest single reservoir of dissolved gases, especially carbon dioxide. They hold about 50 times more CO2 than the entire atmosphere. With the water gone, this immense store of gas would be liberated almost instantly. Trillions of tons of carbon dioxide, along with methane from methane clathrates on the seafloor now destabilized by the lack of pressure, would erupt into the air. The sky would darken, not with clouds, but with a sudden, choking blanket of greenhouse gases. But the most immediate atmospheric change would be the death of the water cycle. Evaporation from the ocean surface is the source of virtually all of our planet's rain. That engine has just been switched off. The clouds you see in the sky would be the last ones ever formed from oceanic water. They would drift, disperse, and then nothing. The promise of rain would vanish from the world, everywhere, all at once. For the first few hours, the newly exposed seabeds would still be wet. Trillions of tons of mud, silt, and organic ooze are now open to the air. As the sun begins to beat down on these vast plains, a fog of epic proportions would rise. But this isn't a clean, refreshing sea mist. It's a fetid, stinking vapor, thick with the smell of decay, salt, and untold tons of decomposing marine life. From the smallest plankton to the great whales, every living thing in the ocean is now dead or dying, exposed on the muddy plains. Their bodies would begin to decompose immediately, releasing vast quantities of sulfur compounds, methane, and ammonia into the air. The smell would be the first true signature of the New World, the stench of planetary-scale death. Humanity's immediate reaction would be shock and chaos. Coastal infrastructure, ports, bridges, undersea cables, is now either destroyed or rendered useless, hanging absurdly over dry abysses. Nations are cut off from each other. The global economy, so reliant on maritime trade, ceases to exist in a single moment. But the true horror has yet to sink in. For now, in those first 24 hours, survivors would be grappling with the endless earthquakes and the terrifying new view from their windows, unaware that the air they're breathing and the climate they depend on are already in a terminal state of collapse. The planet is just beginning to scream. After the initial shock, the quakes, and the atmospheric belch, a new era of discovery would begin, albeit a morbid one. Humanity, or what's left of it, would be staring at the largest uncovered artifact in history, the ocean floor. The world's maps are now obsolete. We have, in essence, discovered a new supercontinent, a territory larger than all the previous landmasses combined. And it is a realm of geological titans. The most prominent feature, now visible to the naked eye, would be the mid-ocean ridge system. This is the true spine of the world, a 65,000-kilometer-long chain of underwater volcanoes that snakes its way around the entire globe. Previously hidden beneath miles of water, it is now exposed as the planet's greatest mountain range, dwarfing the Andes, the Rockies, and the Himalayas. Its peaks would soar, wreathed in toxic steam and newly erupted ash. The volcanic activity, once suppressed by the immense pressure of the water, would intensify. Fissures along the ridge would split open, spewing lava and noxious gases directly into the thin, dry atmosphere, creating a permanent, poisonous haze that would circle the globe. These seams of the earth would be a no-man's land, a landscape of fire and brimstone straight out of a Bosch painting. Then there are the trenches. The Mariana Trench, once the deepest point on Earth at nearly 11,000 meters below sea level, is now an accessible, albeit terrifying, chasm. Standing on the precipice of the Challenger Deep would be an experience unlike any other. The drop would not be a sheer cliff, as often imagined, but a long, sloping descent into a narrow, shadowy valley. The pressure that held its walls in place is gone, and the rock, squeezed for millennia, would begin to crack and fracture, causing constant rock slides and further seismic instability. Exploring these trenches would be like exploring the deepest canyons of an alien world, revealing the strange geology of subduction zones where one tectonic plate is forced beneath another. But perhaps the most alien features of this new world would be the hydrothermal vents. The black smokers and white smokers, once home to unique ecosystems of chemosynthetic life in the abyssal dark, are now exposed. They would act like hellish geysers, spewing superheated water, rich in sulfur and heavy metals, hundreds of feet into the air. The water would flash evaporate, leaving behind glittering, poisonous towers of mineral deposits. The extremophile bacteria, tube worms, and blind crabs that thrived here would be instantly boiled or poisoned by the oxygen in the air, their strange forms fossilized around these toxic chimneys. These vents would become bizarre oases in the desolate plains, deadly yet mesmerizing monuments to a form of life that existed entirely without the sun. Away from the ridges and trenches lie the abyssal plains. We imagine them as flat and featureless, but the reality is far more complex. These vast expanses, covering more than half of the Earth's surface, are not sandy deserts. They are covered in a thick layer of fine sediment and marine snow, a continuous rain of dead organic matter, plankton, fecal pellets, and dust that has been accumulating for millions of years. Now exposed to the sun and wind, this organic-rich ooze would begin to dry, crack, and be whipped up into colossal dust storms. The smell of decay would be overpowering, and scattered across these plains would be a museum of history. The wrecks of countless ships, from Spanish galleons to World War II battleships, would lie exposed, their wooden hulls or steel plates rapidly corroded by the salt-laden air. The Titanic, no longer resting in peaceful darkness, would sit on a dry, dusty plain, a ghostly monument to a bygone era. Lost submarines, downed aircraft, and even the discarded stages of space rockets would litter the landscape. We would also find the footprints of our own carelessness. Mountains of plastic waste, fields of discarded fishing nets, and barrels of nuclear and chemical waste, their containers now breached and leaking their poison into the nascent dust bowl. But the plains hold deeper secrets. The skeletons of Megalodon, Basilosaurus, and other prehistoric sea monsters would lie half-buried in the dried mud, their immense scale finally visible. The ocean floor is the ultimate fossil bed, and its draining would trigger a golden age of paleontology, even as human civilization itself crumbles. This new world, born from the death of the old, is a land of terrible beauty and profound revelation, a stark testament to the history of the planet and the hubris of humanity, all laid bare under a hostile, unforgiving sun. The geological and historical revelations would be fascinating to a scientist, but for any surviving life, the atmospheric changes would be the true executioner. With the planet's primary thermostat, the oceans gone, Earth's climate would spiral into an extremist nightmare. Water has a high specific heat capacity, meaning it can absorb immense amounts of solar energy without its temperature rising dramatically. It stores the sun's heat and distributes it around the planet through currents, moderating our climate. Without this global regulator, temperature differentials would become savage. The daytime side of Earth, particularly the equatorial regions, would bake under the unfiltered sun. Surface temperatures on the dark, dry seabeds could soar well above the boiling point of water. At the same time, without the ocean's retained heat and the insulating blanket of water vapor, nighttime temperatures would plummet catastrophically, reaching far below freezing, even at the equator. This daily swing from scorching inferno to deep freeze would shatter rocks, pulverize soil, and make the surface utterly unsurvivable for any complex life. This extreme temperature gradient between the old landmasses and the newly exposed, rapidly heating ocean basins, and between the day and night sides of the planet, would create pressure differences on a scale the Earth has never seen. The result would be wind, not storms, not hurricanes, but hyperhurricanes. Continent-spanning, perpetual wind systems would scour the face of the planet. These winds would pick up trillions of tons of dried salt from the former seabeds, along with the fine, dusty sediment of the abyssal plains and the toxic ash from the hyperactive mid-ocean ridges. The air would become a constant, abrasive fog of salt, dust, and poison. Visibility would drop to near zero in vast regions of the planet. The salt would encrust everything, kill any remaining vegetation, and make the already scarce fresh water undrinkable. These global dust storms would block out the sun for weeks or months at a time, plunging the world into a dim, freezing twilight, only to be followed by periods of blistering, unfiltered solar radiation when the dust settles. The water cycle, the gentle engine of life, would be replaced by a brutal dust cycle, a grinder that endlessly circulates grit and poison. The very composition of the air would become hostile. As we saw, the initial event released a massive pulse of CO2 and methane. But the process wouldn't stop there. The death of all plant life on land, which would swiftly follow the cessation of rain, would mean the end of photosynthesis. The planet's primary mechanism for scrubbing CO2 from the air and producing oxygen would be shut down. Over time, as geological and chemical processes continued to release gases, the atmospheric oxygen levels would begin to fall, while CO2 levels would continue to rise. Earth would be on a one-way track to becoming a high-pressure, CO2-dominated world, not unlike Venus. The thin ozone layer, no longer replenished by processes linked to oceanic life, would degrade, allowing lethal levels of ultraviolet radiation to sterilize the surface. Breathing the air would become impossible without advanced filtration systems. Any survivor would have to contend not only with the killer winds and temperatures, but with an atmosphere that was becoming progressively more toxic and corrosive. The sky, once blue, would become a permanent, hazy brown or a sickly yellow-orange, colored by dust and chemical smog. Earth would be a planet actively trying to sandblast, poison, and irradiate any hint of life from its surface. The gentle breezes and life-giving rains of the past would become a distant, mythological memory in a world defined by a single, brutal certainty. The air itself is the enemy. In the face of this planetary cataclysm, life's prospects are grim. The first victims are, of course, the inhabitants of the ocean. In a single moment, an estimated 95% of the planet's biosphere by volume is extinguished. Whales, dolphins, fish, corals, krill, the entire intricate web of marine life ceases to exist. It is the most profound and instantaneous mass extinction event in the planet's history, dwarfing the asteroid that killed the dinosaurs. The land does not fare much better. The cascade of collapse is swift and merciless. With no rain, terrestrial plants are the next to go. Within months, forests, grasslands, and jungles would wither into brown, desiccated tinder, fueling continent-spanning firestorms sparked by lightning from the dust-filled skies. This removes the foundation of nearly every land-based food web. Herbivores, from insects to elephants, would starve. The carnivores that prey on them would follow soon after. The intricate ecosystems that took millions of years to evolve would be wiped clean in less than a single year. So, what of humanity? Our technological prowess gives us a fighting chance, but a slim one. The initial earthquakes would have already devastated our cities. The breakdown of global trade means no food, no fuel, no medicine. But the ultimate challenge is water. With all surface water gone and no rain to replenish it, the only source of fresh water is locked deep underground in aquifers. Humanity's survival would depend on a frantic, desperate retreat. We would have to abandon the surface entirely, constructing sealed, self-sufficient habitats deep underground or in mountainside bunkers, powered by geothermal or nuclear energy. These subterranean arcs would be our only refuge from the lethal surface conditions. Life would become a permanent state of siege. The primary occupation of these bunker-bound survivors would be drilling for fossil water, recycling every drop, and growing food in hydroponic bays under artificial light. They would be prisoners on their own planet. Contact between the scattered bunkers would be difficult, if not impossible, across the storm-racked, hostile surface. Humanity would likely fragment into isolated pockets of survivors, each developing in its own unique way, their knowledge of the old world slowly fading into legend. The surface of Earth, the world of sunshine and blue skies, would become their space, a deadly vacuum they can only visit in sophisticated protective suits. Could any other life survive? Perhaps. In the deepest recesses of the Earth's crust live communities of microbes known as endoliths, bacteria and archaea that subsist on chemical reactions with rock, entirely independent of the sun or the surface world. They would be utterly oblivious to the apocalypse above. On the surface, perhaps a few incredibly hardy extremophiles could cling to life. Some species of lichen or incredibly resilient desert insects might find niches in the more sheltered canyons, surviving on minute pockets of moisture that condense during the freezing nights. The newly exposed hydrothermal vents, while spewing poison into the air, might provide the chemical energy for new, bizarre forms of chemosynthetic life to evolve at their bases, creating tiny, toxic oases of microbial life in the vast desert. But these are faint sparks in an overwhelming darkness. The planet would be, for all intents and purposes, sterilized. The grand, beautiful, and complex experiment of multicellular life on Earth would be over. The survivors, human or microbial, would be mere ghosts haunting a planetary tomb. For any human looking out from a reinforced viewport in their subterranean shelter, the view would be one of ultimate loss, a brown, dusty, storm-choked planet that was once their vibrant home. They would be the curators of a dead museum, their only task to remember a world of green trees and blue oceans that they can never touch again. In the aftermath of the Great Dying, what does Earth become? Millennia pass. The relentless, salt-laden winds have eroded the old continents and the new mountains of the mid-ocean ridge, softening their features. The planet has settled into a new, terrifying equilibrium. It has not become a second Mars. The thick, CO2 heavy atmosphere has created a runaway greenhouse effect, keeping the planet ferociously hot, even with the dust blocking much of the sunlight. It has not become a second Venus. The lack of water vapor, a crucial greenhouse gas, prevents it from reaching those hellish surface temperatures. It is something unique, a sterile, high-pressure desert world trapped in a perpetual state of toxic twilight. The vast abyssal plains are now endless salt flats, shimmering with poisonous mineral deposits. The great trenches are simply deep valleys filled with reddish, choking dust. The memory of water is gone, scrubbed from the geology itself. The planet has a new name among the scattered, subterranean descendants of humanity, should they survive: the brown marble, or perhaps simply the ruin. The relics of our civilization are still there, half buried by the shifting dust. The pyramids of Giza, eroded but recognizable. The foundations of New York, a grid of ghostly lines in the desert. And out on the salt flats, the corroded hulk of the Titanic, a silent testament to a world of hubris and ambition that drowned not in water, but in its absence. This thought experiment, this journey into a hypothetical apocalypse, serves a profound purpose. It forces us to see our world not as a static backdrop for our lives, but as a dynamic, fragile, and interconnected system. The ocean is not just water. It is the planet's blood, its breath, and its memory. To remove it is to witness the autopsy of a world. It reveals the hidden machinery of our home, the geological skeleton beneath the skin, the atmospheric nerves, the circulatory system of currents that keeps us alive. We look at the blue marble from space and see a symbol of hope. But this exercise reminds us of the razor's edge on which our existence is balanced. It reminds us that the line between a living world and a dead one is terrifyingly thin, and we are, all of us, living on the edge of the abyss.